David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember you can adjust the playback speed to make it faster or slower as you like. Second, you can pause the video at any point to catch up on your notes or jot down some questions. Third, you can turn on the captions so you can read my words on the screen. Today's topic is a review of this advanced trigonometry chapter that we have been working through. So one of the key concepts here is the unit circle. And it's worth reviewing some of the basics of the unit circle. My hope is that you already have this wired. Okay, the unit circle is a circle centered on the origin of the coordinate plane, the xy coordinate system, and it has a radius of 1. R equals 1. And that makes for some interesting things that we can do with this unit circle. The first thing is that if you rotate some angle theta, and remember theta goes positive in a counterclockwise direction, if you rotate up theta so that now you're at point P on the outside, the xy coordinates of theta are given by cosine theta and sine theta. So you can just use a calculator to find those, or you can work a trigonometric expression using this information. Finally, another thing to know that we developed a little later in the chapter was that the tangent of this theta, right here, is equal to sine theta divided by cosine theta. So now we have all 3 of those trig functions are all related here and shown on the unit circle. Now we talked about how we measure the distance around the unit circle. Now everybody's familiar with degrees, 360 degrees in a circle. That's great. Well, in this unit we use radians to go around the circle. And it's kind of interesting. The way radians are defined is it takes 2 pi radians to go all the way around. So that's like 6.28 radians, but we never convert the pi to a decimal. We always just leave pi in our answers. And this makes things simple a little later, especially when you get into more trigonometry in 11th and 12th grade. Finally, we had an acronym to help us remember the signs, S-I-G-N, positive or negative, of the 3 trig functions in the quadrants. Quadrant 1, 2, 3, and 4. And here's the acronym. All silly turtles crawl. So what that helps you answer is what is positive in each coordinate, in each quadrant. So all means that in quadrant 1, they're all positive. In quadrant 2, only sine is positive. So over here, cosine and tangent are both negative. In quadrant 3, tangent is negative. So down here, tangent is the only function that is positive. Finally, in quadrant 4, cosine is positive. So to review that real quick, quadrant 1, sine positive. Quadrant 2, action. Okay, to review that real quick, quadrant 1, all 3 functions positive. Quadrant 2, sine is positive. Quadrant 3, tangent's positive. Quadrant 4, cosine is positive. Okay, let's take another look at that unit circle. There's 4 main points that are super easy to remember. Remember how we talked about when we went around that circle, any point P, the coordinates are cosine theta, sine theta. Okay, so these 4 points, here, 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 and here, are super easy. Remember, the unit circle has a radius of 1, so when we're out here, we're at the point 1, 0, because we've come 1 from the origin along the x-axis. Similarly, when we're up here, we're at the point 0, 1, because we come up 1 on the y-axis. Over here, we're at negative 1, 0, and finally on the bottom, we're at 0, negative 1. So if you were to take the degrees for this, remember this is 90 degrees right there, theta equals 90, and put that in your calculator, you're going to get cosine 90 is going to be the x-coordinate, which is going to be 0. You could do that right now and you'll see that's what you'll get. And sine of 90 is 1. And so similarly, as you go all the way around the circle, cosine 180, negative 1, let's say all the way to here is 270. So the sine of 270 is the y value. So sine of 270 would be negative 1. And you can go all the way around the unit circle and it's going to do that for you. We also took a look at this trigonometric identity. Cosine squared theta plus sine squared theta equals 1. This is always true for any theta. So a question you might get is, what is sine theta when cosine theta is 1/2? So this is basically simple algebra here. Cosine theta is 1/2, so cosine squared theta will be 1/2 squared plus sine squared theta equals 1. This becomes 1/4. 1/2 squared is 1/4. Subtract a quarter from each side. Sine squared theta equals 3/4. Take the square root of both sides. Sine theta equals root 3/2, and don't forget your plus minus. Then we started looking at the unit circle, and our first walk around in terms of certain angles was we spent a lesson looking at multiples of 30, which would be 30, 60, and then we also looked at multiples of 45. So I've drawn quadrant 1 of the unit circle so we can take a look at that. So here we go, 30, 45, 60 degrees, which is the same as pi over 6, pi over 4, and pi over 3 radians. And we did a little bit of geometry, and we showed that the x and y coordinates at these 3 points are given by these little expressions there. So at 30 degrees, the x coordinate is root 3/2, y coordinate is 1/2. Then at 45, we have 1 over root 2, 1 over root 2. And lastly, at 60 degrees, we have 1/2 and root 3/2. So you can be asked questions like, what is the value of sine theta when theta is 45 degrees? And so what you do is you come up to 45 degrees and you look for sine theta. So sine 45 is 1 over root 2. So when you get questions like this on a test or a quiz, you can't put that in your calculator. You have to use the unit circle to give this value, 1 over root 2. Now, if you put sine 45 in the calculator, you're going to get a decimal. That decimal is the same decimal you'll get if you divide 1 by the square root of 2. So let me ask that question a little differently. What is the value of cosine pi over 3 radians? What would that be? So pi over 3 radians happens here at 60 degrees, and cosine is the x-coordinate, so cosine of pi over 3 radians is just 1/2. We spent a lesson looking at trigonometric functions graphed in a different way. So with the unit circle, we're graphing the values of sine and cosine as we go around the circle. In this graph, I've got theta on the horizontal axis and sine theta on the vertical axis. And as you recall from the unit circle, sine theta varies between 1 and -1. And so here's our max at 1, and here's our minimum at -1. And then it just bounces around between those two values. So what I've done is I've graphed this over 90, which is pi over 2 radians, 180, 270, and 360, which is 2 pi radians. So this is one circuit around the unit circle, but this graph is kind of reeled out. The unit circle goes round and round and round. The sine graph, like this, just goes up and down forever. But it's the same relationship, okay? So now you can read values. Like, if we're at 0.5 here, you can read the graph across, and you can find out what value of theta, what theta is when sine theta is 0.5. Conversely, you can read the graph by going, oh, okay, so what is the value of sine theta when theta is pi radians? So I'd go here to pi radians, that's 180 degrees, and I can see that sine of pi radians is 0. So this graph shows pretty much the same thing the unit circle shows, it's just a different format. Now the cosine graph looks almost the same, but instead of starting at 0, it starts at 1 and goes down and up and ends back at 1. But it's the same cyclic nature of the function. It's just shifted 90 degrees. We also worked on simplifying trigonometric expressions. So these problems don't connect to the unit circle. You're just using algebra rules to simplify the expression. So this first one, we have 6 sine thetas minus 2 sine thetas. This is really simple. This just becomes 4 sine theta. And that just kind of makes sense. I have 6 of them here minus 2 of them. I'm going to wind up with 4 of them. That's pretty good. Okay, this one here, we have 3 sine squared theta plus 3 cosine squared theta. So the first thing I'm going to do is factor out my 3. I'll get 3 times sine squared theta plus cosine squared theta. Now, what do you think that's going to end up being? Think back to the sine squared theta plus cosine squared theta identity. That's just 1. That's this whole thing. So this is 3. So that's simplified down quite a bit. Okay, this last one has you simplify the expression based on factoring patterns. And if you'll notice, this is one thing squared minus another thing squared. So that fits this pattern, a squared minus b squared. And we know from factoring that this is a plus b times a minus b. Okay? So we can use this pattern to factor this into sine alpha minus cosine alpha times sine alpha plus cosine alpha. Okay? So 3 simplifying expressions. We also worked with trigonometric equations where we were asked to solve and find theta. So here's an example problem you might see. If sine theta is root 3 over 2, find theta. Now the key to this is understanding your unit circle. So if I take a look, I know sine theta is the x-coordinate, and so I can look on my unit circle and I can see that that's somewhere up here is where we have the point 1/2 comma root 3 over 2. Now there's another place where y is root 3 over 2, and that's reflected across the y-axis right up there, where I'd have negative 1/2 comma root 3 over 2, right there. So to find theta, all I need to do is find that angle. That's the first theta. There's 2 values of theta that give us a y value of root 3 over 2. So theta 1 right there, and then theta 2 right there. Let's call that theta 2. So again, I can just read that right off my unit circle diagram. This one, theta equals, what have I got? Pi over 3, which is 60 degrees. And this one, this would be our theta 1. Our theta 2 is going to be 2 pi over 3, which equals 120 degrees. Now these questions will have ranges, often have ranges connected to them. So they might say like 0 is less than theta is less than 360 degrees. And that tells us that all we want are the thetas that are in one circuit of the unit circle. I could also write 0 is less than theta is less than 90 degrees. And then my answer would only include this one, because this value for theta happens past 90 degrees. So you got to pay attention to the ranges. Now that you've watched the video, take a moment to jot down any additional notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.